today's webinar, which is all about natural materials for retrofit. And today we are particularly looking at walls, windows, and floors. So today's event is part of a series of events in the natureplus European event series. So delighted to be co-hosting events with our partners across Europe. So natureplus, Agridome, Baubao Swiss, and EBO. I'll give a bit more of an intro to natureplus in a moment. So today's event is the second of 5 events. So we kicked off yesterday with another event looking at natural materials and windows. And then there's 3 more events coming up next week. So please do check out the natureplus website. I'll put the link up in a moment. And we are recording all of these events as well, so you can catch up in your own time. So yeah, a pleasure to be co-hosting with our partners across Europe. Just like to thank Pro Holtz Fenster, Berg and Berg, and Isolina for supporting the series. So on to today's event, we're delighted to be joined by 3 ASBP members. So welcome to Neil Turner, Technical Manager at Ecological Building Systems, who will be talking about their internal wall insulation solution. And then we have Nicola Harrison, Managing Director at the Berico Group, who will be presenting on their work, some really fantastic timber window case studies. And then we have Peter Rollinson from Mike Y, who will be presenting on their recycled glass and limecrete flooring solution. So, and then we'll have time for some Q&A, and we'll wrap up at 2:30. So just a few instructions for today's event. If you can add any questions, so you can add questions throughout the webinar. If you add them to the Q&A and not the chat, that way people can upvote and comment on your questions, and we'll start with the most popular question. Please do not use the raise hand option. If you've got any technical issues, just write a message to myself, Richard Broad, or my colleague Larry Tate in the chat. And we are recording today's webinar. So just a quick intro to the ASBP. So we are the Alliance for Sustainable Building Products, and we are a not-for-profit mission-led sustainability organization. And this is our mission: to transform the built environment to be healthy and low carbon. And we have a big focus on sustainable building products. And we have quite a wide range of activities. So we do lots of knowledge sharing through webinars, events, conferences. We lead and partner on research. We create lots of guidance and toolkits. We're very collaborative. We love to partner with like-minded organizations. And then we seek to influence policy through consultation responses and lots more. And we do this through what we call our 6 pillars of sustainable construction. So these are our themes that frame our activities, and this is our holistic viewpoint of sustainability. So looking at health and well-being, resource efficiency, whole life, embodied carbon, and lots more. So we'd love for you to get involved with our work, so you can partner with us on research. Some of our recent focuses have been on really quite diverse, the reuse of structural steel. So there's some real embodied carbon wins to be had by reusing instead of recycling. We've had a research project looking at timber and biodiversity, and then natural materials and retrofit, which of course we're talking about today. And then we have a number of special interest groups, one looking at natural insulation, one looking at healthy paints and finishes, and then a cross-sector group on reducing plastics in construction. And our membership, we're pleased to say our membership is growing. We've had 50 new members this year, so our membership is now over 160 members, 20 patron members. So please do consider joining ASBP. If you'd like to find out more about us, there's loads of free resources, guidance, toolkits on our website. So go to asbp.org.uk to download those. We're just planning our events series for our events plan for 2025. So keep an eye on our website for upcoming events. And then our awards, we're planning something a bit special for next year. So we're collaborating with one of our partner organizations to do something bigger and better. So more info to be announced soon. But yeah, that will open for entries in the spring, and we'll have a ceremony in the summer. So just a couple of events to wrap up the year. I think this has been our busiest year ever in terms of events. We must have had 3 or 4 a month. So we're ready for a little break over Christmas before we start again. So yeah, please do check out the European event series. There's 3 more events next week. Tomorrow we have an event chaired by my CEO, Simon Corby. So this is republication of the Mass Timber Insurance Playbook, which has been a incredibly successful and well-received document, and it's received further endorsement from some major organizations such as the Association of British Insurers, which is a real endorsement. So please join that event to find out more. And then our final event of the year is a meeting of our patron members. I mentioned we have over 20 patrons now, which is fantastic. So this is an opportunity for them to meet each other, feedback on our work over the last year or so, and then we can inform them what we're planning for the coming years. And this is sort of our biggest event of the year, so our annual Healthy Buildings Conference. So we've confirmed the date and venue. So this is Wednesday, the 26th of February in London at the Human Rights Action Centre, Amnesty International. So this is our 9th event. We're joined by, hopefully joined by Mary Cray, who's the Minister for Nature at DEFRA. And we've confirmed John Palmer from MHCLG. We'll be sharing the findings from our impact project, which has been looking at traceability, transparency and biodiversity in mass timber supply chains. We have a really interesting case study. So this is I think it's being constructed at the moment. It's a cross-laminated timber building, 7-story in Cardiff, residential. So it'll be really interesting to hear more about that. And then we have research findings on healthy indoor environments, VOCs, and some panel discussions on biogenic carbon and regenerative design. So quite an action-packed day. Please do sign up and join us. It's 25% off tickets, early bird discount until the end of the month. We do have some exhibition and sponsorship opportunities available. Just like to thank One Click LCA for being our platinum sponsor this year, and PEFC as our bronze. And I believe we've just confirmed Urban as our silver sponsor. So they're going fast. So please get in touch if you'd like to support the event. And a quick intro to natureplus. So we are the UK representative of natureplus. So they're a similar organization to us. They're a non-profit membership network with a mission, and their focuses are on climate protection, healthy living, and conservation of resources. And they're probably best known for their eco labels, which is a very stringent product. Eco label considers health and well-being, indoor air quality, embodied carbon, etc. But they also do a range of activities. They have events throughout the year. They have guidance, consultancy, and a really useful database of natureplus certified products. So we're the UK rep, but we're delighted to partner with partners in the Netherlands, Switzerland, Italy, Germany, and Austria. So if you're interested in finding out more, head to the website. Okay, so that's my intro done. So I'd like to introduce our first speaker. So Neil Turner, UK Technical Manager at Ecological Building Systems. Over to you, Neil.
Okay, well, thank you, Richard. I'm just going to share my screen. Okay, so can you see that, Richard?
I can see it. Perfect. Thank you.
Okay. Well, thank you very much. Well, good afternoon, everybody. My name's Neil Turner. I work for a company called Ecological Building Systems. And what we do as a business, we supply the whole ProClima range of air tightness, membranes, tapes, and seals. But then we also supply a range of natural insulation products. So we supply wood fiber, hemp, jute fibers, and also a new product from grass that's made from grass. For some reason, I've locked up. Here we go. So just say a little bit about myself. I'm a bit strange, really, because I'm a scientist by education. But for the last 25 years, I've worked in the construction industry. Most of my experience is manufacturing warm cell cellulose insulation. But I've been with Ecological 9 years now. So I'm still involved in a couple of CEN, Committee for European Norm standards, looking at test methods and developing new standards for new insulation products. And I'm also a member or a former member of the Thermal Insulation Manufacturers Association Competent U Value Scheme. So what I'm going to talk about briefly this afternoon is an internal wall insulation system for solid masonry. And I'm going to start by talking about the challenges of insulating solid masonry walls as opposed to cavity walls, and some of the features that you have to consider. I'm then going to talk about what we call our retro eco wall system. So it's a combination of an insulated cork lime thermal plaster. So that's used as an insulating base coat. And then you use natural wood fiber insulation. And then I'll summarize. So in terms of insulating, retrofitting buildings, the biggest issue that you can have with existing buildings is actually moisture. So except for structural errors, about 90% of all building construction problems are associated with water in some way. And this is a particular challenge when you're looking to internally insulate buildings, solid wall buildings. So if you look at the UK as an example, we have a number of different types of solid wall. So you can have a solid brick wall or a rubble stone wall, and then combinations of rubble stone wall with brick backing, or you can have ashlar stone with brick backing or ashlar stone with rubble backing. Now, in the UK, it's estimated that we have about 8 million properties which are solid stone wall. Now, the main difference between solid stone wall and what you see up here, a cavity wall, and this took off in the UK in the 1930s. But what you have with a cavity wall, all things being equal, is that your inner leaf is actually protected from the effects of wind-driven rain by the outer leaf and the cavity. So it's less risky to insulate internally on a cavity wall than it is on a solid wall. So what you don't want to be doing is insulating your wall internally if there is a moisture problem. So if we look at this picture here, it's showing the sort of primary drivers of how moisture can ingress and transport through a solid wall. So obviously the biggest influence is external climate. So you've got wind-driven rain, snow, frost, and humidity. You've also then got obviously internal moisture. So that could be from cooking, washing, breathing, and just normal indoor activity contributes to indoor relative humidity inside the building. You can also have quite a bit of built-in moisture within building materials. And also you can have rising moisture from ground level. Many of these old buildings don't have damp-proof courses, damp-proof membranes. And it's actually encouraged in some cases for moisture to be able to move both from outside to inside and inside to outside. So if you look at the mechanisms of moisture transport through a wall, it could be vapor diffusion, vapor convection, and also capillary action and surface diffusion. In terms of heat transfer, heat can transfer through a wall via conduction, convection, or radiation. And that's one thing that you have to take into account, actually. If you've got a south or a west facing wall, then moisture can actually be driven from outside to inside by the solar impact. So in terms of insulation, if you're looking at internal insulation, I know in Europe, many people opt for external wall insulation. But what tends to happen in the UK, a lot of these buildings, the solid masonry buildings, for planning reasons, you're not allowed to insulate externally because you're changing the appearance of the building. So many people opt for internal wall insulation. And there's basically two types of approaches that people adopt. So you can either use what we would term as breathable moisture vapor diffusion open insulation, or some people opt for non-breathable vapor closed insulation, such as insulated plasterboards. One thing to consider is that when you insulate internally, you can have a big impact on the moisture behavior of a wall. So if you look at the picture at the top, what you see here is you've got a wall that has no internal insulation. And let's say that it's got, a nice lime finish internally as well. And what you can see here is that moisture can harmlessly penetrate into the wall, but it can also escape via diffusion. And then in the summer, it can harmlessly diffuse back. The moisture vapor can diffuse back into the building. So what tends to happen with this dynamic is that your moisture content never reaches a critical dangerous level, because the moisture can be ingress and egress the building. However, if you look at this picture on the bottom, what we've done here is we've now insulated with a non-breathable insulation, such as an insulated plasterboard. Now, the issue that you've got here is that you can still get diffusion of moisture from internal to external, but what is restricted is this so-called movement of moisture from external to internal, especially in the summer. And that's why we promote breathable insulation material internally, because their moisture can actually diffuse back through that breathable insulation and not cause a moisture buildup. The other thing to consider is you should always avoid still air gaps between insulation and your wall. This is a common technique that you see in the UK, where people actually use what they call dot and dab. So you've got this insulated plasterboard that's not breathable, and it's being dotted and dabbed onto the wall. And then that's trapping cold, moist air behind. So what we always promote are full contact systems, so that you've got a clear moisture diffusion pathway and no potential for mold or condensation in the cold still air gap. It's always a good idea when you're insulating internally on a solid wall to do a hygrothermal assessment. So the most common system used is actually WUFI. There is another technology software program called Delphin as well. But quite often, a lot of clients will just use the condensation risk software that you have with the U-value package. And that's known as a sort of glazer calculation. Whereas WUFI is, it's got a lot more information that it calculates. So you've got real climatic data, you've got inside, outside temperature, you can set the inside humidity depending on what you're predicting the inside humidity is. It also takes into account the absorption of light. So if you've got a dark brick or a dark stone, that can actually absorb more heat than something that's very pale in color. You get more reflection, so you can potentially get more summer back drying with a darker masonry. But basically, the standard that Woofy operates to is EM 15026, and it's more reliable for solid masonry walls than the Glazer method. Now, in addition to breathability, another benefit is if you use insulation materials, which are what's known as water capillary active. In other words, they can absorb some moisture, but then harmlessly release it when the climatic condition changes. So capillary action is all about the force that causes moisture to rise against the force of gravity. And I'm going to show you three examples here. So on the left, you've got wood fiber insulation. So wood fiber insulation is not really, doesn't have a high degree of water capillarity. The one in the middle is a calcium silicate board. That's very highly water capillary active. And then on the right, you've got a cork lime thermoplaster, which has some degree of water capillarity. So water capillarity is always a good idea to consider in these scenarios. If you've got a brick that's either very thick or very thin, if you're in an area that's very exposed to wind-driven rain, if you've got low capillarity on your internal surface, so if somebody's put a cement render on a wall and they can't remove it, then maybe consider a water capillary active system. And then the other two things are mortar joints, where you've got highly vapor resistant stone, such as granite or those kind of materials. Okay, so this is our sort of main internal wall system. And it kind of incorporates all of the things that I've just said. So if you look at this picture on the right, this is at our display stand at the NSPRC in Swindon. What you have here is a lime level coat, and it's actually, we actually promote the use of diathanite as well, which is an insulating lime layer, and I'll explain more about that. And then basically you're then bonding wood fiber insulation onto the lime level coat. And then basically what you're then doing is that you're finishing off with a lime plaster and then breathable paint. And then there's other accessories as well, such as corner beads, mesh, sealing strips, and those kind of things. So this is just showing another schematic, if you like. So this is your water capillary active insulating lime level coat. And you notice here that you're getting a full contact between the insulation and the wall. That there are no air gaps whatsoever. So there's no potential to trap cold pockets of still air, which could give rise to mold. In the Gutex system, the Gutex one we supply, if the wall's less than 3 meters, they recommend that you can just bond it with an adhesive, a breathable adhesive. If it's higher than that, then they recommend using fixings as well. I always like to show this in window reveals. It's always a good idea to install a thin layer of insulation. If you don't have any insulation in the reveals, you can get cold bridging, cold spots, and mold as well. So this is just the process. So you've got your lime level coat. So you're smoothing off and creating a situation where you've got full contact with the wall. And then you then apply your wood fiber, and then this is your lime green skin. Just say a bit more about the diathanite Thermactive. So this is a product that we've been supplying now for quite a number of years. It's actually an Italian product. It's called diathanite Thermactive. So it contains cork, it contains lime, so that's a mixture of hydrated lime and hydraulic lime. And then it contains other additives such as perlite, silica, and pumice, and various other ingredients. So this material is breathable. It's got very highly moisture vapor diffusion open. And it's got a thermal conductivity of 0.037. So we've had all of this now tested by the BBA in Watford as well, which confirms those figures. Um, it's got quite a low density. You can either apply this by hand or by machine. And it's also Eurofire Class A1 non-combustible. Um, and it's tri-functional. It's acting as an insulating level coat, so you get full contact. Also, it's a moisture buffer because it's water capillary active. And also, it's an airtight layer. We've actually done some Retrofit projects where this has been the airtight layer as well. So the benefits of wood fiber insulation and other natural fibers, obviously you get good insulation in the winter, but also these products tend to have a high specific heat capacity, and they're relatively dense, so you actually get a reduction in summer overheating as well. Wood fiber is really good acoustically. Um, Also, it's really quick to install. It's just like a tiling process. Richard mentioned Nature Plus. I think all of the wood fiber products are Nature Plus certified, all of the ones on the market. And again, they're breathable. This is just showing the kind of U values that you can achieve. What we always say to people is that do not try and over insulate a solid masonry wall. I know the ASBP and the Natural Fiber Group has done a lot of work on this. You tend to get your biggest bang for the buck with the first 50 millimeters of insulation that you install. But the theory is if you over insulate, you make the interface between the existing masonry wall and the insulation much colder. And then you've got more potential for what's known as interstitial condensation. So you're typically looking for U values, maybe 0.5 down to 0.4. Some clients try and go down to 0.3, but that's when this is when it becomes very important to model properly with the WFI software. So in summary, the system is moisture vapor diffusion open. You've also got a water capillary active base coat, so you can actually absorb a bit of moisture which may transfer through the brick or the stone, and then it gets released when climatic conditions change. You've got full contact with the wall, so there's no still air gaps. And obviously, these natural materials have really good carbon profile. So a lot of these materials, like wood, for example, it's absorbing CO2 when it starts its life as a tree and releasing oxygen. And then when you build with these materials, you're then locking that stored carbon into the building as well. So I think I've just about done 19 or 20 minutes. So that's a very brief overview of our Retro Eco Wall system. Thank you.
Excellent. Thank you, Neil. That was a fantastic presentation, as always. So there are a few questions in the chat. Perhaps we can pick up on a couple now. So I'll ask this one from my colleague, Catherine, who's a circular economy expert. So she asks, where does the recycled cork come from for your Dathanite product? And can it be reused or recycled at end of life?
Okay, so the recycled cork is actually coming from the wine industry. And the Dyson has some schemes. You've got your newspaper collection schemes. Well, they've set up, send us your sort of used wine cork bottle scheme, so that they have to, clean and cut off where you've got the wine. The end of life element is a bit tricky actually with lime plasters, because it's very difficult to recycle and reuse. But we come across buildings that are several hundred years old, which have still got kind of ancient lime on them. The other thing about the wood fiber is that if you bond it, then it's difficult to recycle it. But if you fix it, you could unscrew the fixings and then reuse the product at the end of life.
Good point. Okay. Catherine says she'll have to drink more wine. I think you drink enough wine, Catherine, but yeah, thank you. Another question. could you use diathanite thermactive as external wall insulation?
Yeah, you can use diathanite externally. What you have to do there is that Diasen produces a finish coat. It's called Argatherm. So you have to apply 2 lots of 2 mil skim over and then paint. The other option that you've got is that Diasen also supplies through colored finish renders. So they're breathable, but they give you weathering resistance.
Okay.
So the answer is yes, you can use externally as well. And also wood fiber for that matter.
Sure. Okay, just one final quick one. A question. Why not use a clay plaster as a finish in your system? I'm sure you could.
You can do that. You know, clients often do things like that.
Yeah.
Obviously, I mentioned that Diasen has proprietary finishes, but very often clients prefer to use other finishes.
Yeah.
But you know, we've got Mike Y here today. There's a lot of clients who put the Mike Y type lime finishes on top of diathanite.
Okay. Excellent. Okay, I think we'll save the rest of the questions for later, but keep them coming in. Excellent. Well, thank you, Neil. And over to our second speaker, Nicola Harrison from Berico.
Lovely. Good afternoon, everybody. Just share my screen here. There we go.
Perfect.
Are we on full screen? Lovely. So yeah, oh, it won't click on. 1 second, I think we've stuck. There we go. So my name's Nicola Harrison. I'm the managing director at Berico. I've been working at Berico now for 20 years. Very passionate about what we do and this level of sustainability in the products and the services that we offer. For the last few years, I've been on a bit of a one-woman mission to change the reputation of window and double glazing companies, especially in the home improvement and retrofit sector. It's still very dominated by the white gold, and I don't think we have a very good reputation. So it's been a mission of mine for the last couple of years to really try and introduce a service and a product to that market that is well deserving of what clients are trying to do with the homes. So today I'm going to do things a little bit differently. We're going to talk a little bit just about the windows, what we do, what we offer, quite briefly, and then we're going to talk about some case studies. So I've got 2 more in-depth case studies and then a couple of projects just to show you. These are projects that we've supplied in the last 12 months, some pretty historic ones, up to some that are a little bit more modern, I suppose you could say, for the last 100 years or so. But each of them presenting some challenges with the clients really wanting to improve the properties for the better, mainly in the realms of energy efficiency and noise reduction is quite a big motivator. So just a little bit about Berico. So we established in 2003. We supply timber windows and doors. Originally, we were supplying them to the construction sector, social housing, big housing developers. 21 years on, we're supplying and installing windows now. We supply to a range of house builders, developers. We also supply to private homeowners and install the windows ourselves. Vast array of projects, everything from new build to commercial projects. We've even just been redeveloping some of the buildings as part of the HS2 development in London. So originally supply only, predominantly, but in 2022 we introduced our installation service for retrofit. We do bespoke timber, sash, casement, tilt and turn windows. We do front and back entrance doors. French doors, French casements, bifolds, sliding patios, so the whole realm really. We've supplied in the region of over 300,000 timber windows and doors in the last couple of decades, so experience is well up there now. Really proud of our green credentials as well. We use only FSC 100% or 100% PEFC origin certified timber. We originally only used FSC, but more recently, the forest that we use introduced PEFC, so we insisted that that also be 100% as opposed to mixed or recycled. We donate £1 for every door that we sell to Buy an Acre from the World Land Trust, and up to just, we've saved somewhere in the region of 300 acres of rainforest. And I'm really pleased to say that 98% of us customers have recommended us. So in terms of the windows themselves, like I said, they're made from timber. That timber predominantly, I would say maybe 95% of those windows are made from redwood, and the remainder from hardwood. The hardwood's a bit more complicated because it's not as easily obtained when you're looking for something that's FSC 100% or 100% PEFC origin, but we will only use hardwood of that calibre. It tends to be quite costly at that level as well. So in terms of the windows, they're manufactured, assembled, and then delivered fully factory finished. The coatings that we use are all water-based, breathable, no heavy metals in that paint whatsoever. So very nice natural materials all the way through. So we're going to go on to talk a little bit about, like I said, some case studies, and we're gonna have a look at a couple a little bit more in depth, and then we're gonna have a look at another couple, and then if we've got time, I'll talk a little bit about the regulation changes that have happened, particularly in existing buildings when it comes to windows, a little bit later on if I get the chance. So this is the first of my case studies today. It's the guardhouse in Winchester. It's got some real history, this one. It's on the site of where William the Conqueror originally built a castle in 1067. Very, very old, lots of historic memories. It was the castle that sat there was extended in the 13th century by King Henry III, and then in the 17th century it was besieged in the English Civil War and partially demolished, and then coming along to sort of 17th century, later on in the 17th century, King Charles II decided he was going to have it as the site of his king's house. Unfortunately never finished by Christopher Wren, but it was subsequently abandoned, and then the site was leased from the Crown to be used as a military barracks, and then the guardhouse was built in about 1901. The guardhouse itself, it was the entrance to the barracks. It was full of cells. It detained naughty prisoners. So inside it was quite rough and ready back in the day. The property itself is Grade 2 listed, obviously with that amount of history and heritage. But in the mid-90s, it was converted into an actual house and a residence. The client that we worked with on this renovation, he bought the property in 2018, and he wanted to modernise it because he was looking to rent the property out. So the challenge that we had was to make it look exactly the same. He wanted to match the design of the original windows as closely as possible, but he had a ambition to get the EPC on this property up from what was an E rating up to a B. And where it's located as well in Winchester, it's now quite a busy main road in the centre of Winchester. So again, he was looking for noise reducing properties, particularly if he was going to be renting it out. So the first thing that we do when we're taking on a project such as this is we go out and survey all the current windows and doors. We're getting the sizes, dimensions, but we're looking for any challenges, I suppose, that the project might present us. And on this one, there were a few rotting frames. The original windows were traditional cords and weights. The surveyor told us it's probably likely that the windows were going to fall apart somewhat when we started taking them out. The internal walls themselves were a challenge. In some places they were up to 250 mil thick, with it being a prison. So we knew that there was going to be some quite extensive damage to those walls when we removed the existing windows, that would then obviously need to be repaired. We had windows in bedrooms, like the couple that you can see here, that were needed to act as escape for escape access, but they didn't comply with the regulations because they were on like a pivot. So again there, and then we needed to match that exterior appearance of these windows as much as we possibly could in terms of glass sizes, the visible frame sections, as well as the colours on the windows. We had to match that cypress green of the frames and the white of the sashes, as well as the horn detail on the sash windows. And then they had to have timber, obviously, because of the historic significance of the building, but he really, really wanted to get that best thermal performance out of it that it possibly could. So what we did with these windows is we did a triple glazed sash window. So it's very difficult to tell from just looking at the windows. The proportions are very similar to what was there originally, but the windows have a 0.8 U value. They have 35mm triple glazing. The client opted for concealed spring balancers in place of traditional cords and weights. But by concealing those spring balancers within the frame, you can't tell the difference. But they also would make maintenance easier in future, rather than having to replace traditional cords and go into the expense of lead or even steel now, if you can sometimes use it, which can be quite costly, and it pushes up the cost of the windows. And whilst they're somewhat more modern, just looking at that external appearance, if we go back to the original picture of the before and after, there's very, very little difference between the two, particularly from a few meters away. Up close and personal, you're going to see that triple glaze unit, but in terms of what we were trying to do in terms of matching that external aesthetic to try and keep it, and that's one of the benefits of timber, really, is we've got flexibility. There's a lot of flexibility in what we do, and how we can do it, because we manufacture the sections ourselves, and those sections can be made to match different proportions. So the sash window itself, we've got a frame section of 140mm for thinner wall configurations. Luckily, in this case, we had up to 250mm thick walls on the inside. So there was the ability to be able to introduce that 35mm glass unit and the triple glazing into the sash window. It was 192mm in total, the profile from front to back on the sash window, but then big walls didn't have any issue in taking them. The other thing that we did on the bedrooms was, in place of the pivot windows that were there, we used a tilt and turn window instead. It was an extra requirement, really, from the client that he added kind of at the last minute, because he wanted to rent it out. But using the tilt and turn meant that by turning the window in, he was getting a bigger, clearer opening than the pivot windows would have allowed. The challenges that this one presented, I mean, one of the things I would say from our experience of doing projects like this and renovations like this is expect it to take some time. We initially estimated that the replacement of all the windows in this house would take about 6 days. It ran into about 8 days, and the majority of that extra time that was needed was mainly in getting a plasterer in to redo all that plasterwork on the inside for it to be completed in full. So now on to another lovely project that has been 10 years in the making, this one. So this project is the windmill in West Chiltington. Another one with some real considerable history. The hill was originally called Meaton's Mill, and it was built at Monkmead, and then it was moved to West Chiltington in 1838, and then first appeared on the maps in 1840. So the official date was 1840. It was refitted in 1865, and it carried on working till about 1822. And then it was stripped of its machinery. The millstones went off to another watermill elsewhere, and then it was converted into a home. It's a smock mill style with the octagonal roundhouse. Originally, it was made of sandstone rubble, and it was tarred. You can see a lovely original photograph there beside the renovation now it's completed. The next stories originally were faced with tarred weatherboarding, and then it had the boat-shaped cap on the top. There's only ever been 2 of the sweeps intact since it was converted into a residence, and additions were made to the southeast and southwest of the property for living areas. So the clients that we worked with on this renovation, they actually took this renovation on themselves and the installation of the windows. They were very brave. So they purchased the windmill in about 2010, but they had, obviously under the circumstances, quite strict guidelines that they had to work towards with Horsham because of the windmill itself. There's another lovely photo from way back when it did have all 4 of its sails. The client started the renovation in 2013, so they created an open plan kitchen diner in the ground floor, and that's when they started installing new windows. But as you can see, not a lot of these windows are very square. The openings were somewhat wonky. They've had to fit them as square as they possibly could within the openings. So that did present somewhat of a challenge. One of the biggest challenges was scaffolding. To be honest, scaffolding a project like this is not an easy job. They got caught up in COVID, and then during COVID, they did the next stage of renovations, which was plumbing, electrics, staircases. Again, they continued to project manage themselves, and at that part, that's when all of the ground floor and first floor windows were installed. And then it's took them another few years to brave the 2nd and 3rd floors. But now they've got there, and in early 23, the scaffolding was erected and they got up to those floors. So these windows, the original mill had crittle windows, but the client wanted timber because they wanted to replace all the timber boarding as well. Horsham Council agreed that they could have the timber, but the client was quite keen on not only retaining that traditional design and appearance and keeping the history of the building, but they also wanted, again, to improve the EPC on it because it was running at an F, and it was too low. They wanted to improve that where they could. So the client went with what we call our heritage flush casement. So it's a casement window where the sashes fit flush within the frame externally. They incorporate 16mm narrow cavity glass units, and that was to retain the slim frames around the edge as much as possible. Obviously, Crittall were quite thin. But they opted for the narrow cavity units just simply because they were trying to get that U value down. They were trying to improve that EPC on this property. And with the narrow cavity units in the flush casement, they managed to hit 1.6 on the U value. Certainly a lot better than it would have been if it was single glazing between 5 and 8. So the renovation took 10 years, like I said, from top to bottom. But they did manage to successfully increase it, and the property is now a D rating, whilst they've managed to achieve some of that. And it was for air tightness as well. And with these windows, the flush casement window, despite it being a heritage window, it's fully draft sealed and weatherproofed. So I've just got a couple of other projects, just very briefly to show you, a couple that we've done and installed in the last 6 months. This one here is some workers' cottages at Market Harborough, built in about 1875. The clients were really trying to improve the energy efficiency of this building. They were embarked really on a low energy retrofit. Again, they opted for a flush casement window that they ended up with double glazing, but a U value of 1.3. Again, the objective for us really as timber window suppliers is to make it look as much as close to the original as possible. So when you see a before and after and it doesn't look all that different, that's the source of pride for us that we've done the job that we needed to. And then lastly, I've got another project. This is Calverley House in Leeds, a lovely manor house built in 1873. This house is actually on the ring road at Leeds, and it's incredibly noisy. It wasn't noisy back in the day, but it definitely is now. So these are timber sliding sash cords and weights windows, and they incorporate 35mm acoustic double glazed units. So the overall window gives a noise reduction of 45 dB, which has significantly improved their sleep of an evening, where the bedrooms face onto the ring road. So yeah, I think from our experience over the last couple of years with this installation service, motivations tend to be around energy improvement and around noise reduction. And with timber, we can really achieve both. The sections are flexible, you're getting a natural breathable material, and yeah, it adds a lovely feel. And I'm really pleased to say that whilst it might take us a little bit longer, and that attention to detail needs to be there, the difference that we can make to a project with timber windows is incredible, really. Do I have a couple of minutes, Richard?
Yeah, maybe 1 more minute, if that's okay.
1 more minute, lovely. So they were my case studies, but I just quickly wanted to talk a little bit about today's standards when it comes to windows and doors, because things changed in June of 22 when there was an update to the building regulations. And whilst there's been a lot of fuss about it in terms of a new build with Part O, it was introduced into existing buildings and then U values were brought down. And there's still, I don't feel that it is fully understood. So I wanted to just give a quick overview of what changed recently And I suppose just a bit of recommendations in terms of what to look for if you are looking for windows and doors, and what to look for when it comes to the fitting. So approved document L, updated in June of 22, basically says windows now must be 1.4 U value, or a window energy rating band of B. And then doors, again, a 1.4 U value and a door set energy rating of B. Unless it's got a glazed area of greater than 60%, then it can be a C. But if you're working on U values, it needs to be a 1.4. So this is one of the biggest changes for the home improvement sector, retrofit sector for many, many years. It's dragged U values down from 1.8, which was way outside really what anybody's been manufacturing for the last 10 years, to something that's ever so slightly under what people have been manufacturing for the last few. So the one thing that I would say here is if you are looking for new windows and doors, then you need to be looking for, on your contracts, on your quotes, you need to look for that U value being proven. This U value has to be proven. They can't just declare it anymore. It has to be proven. So you're looking for a U value calculation or a thermal report. Your contract should show the U value for each window and door that you're ordering. And in the case of the window energy ratings and door energy ratings, you need to being supplied by a manufacturer with BF4C certification or equivalent, and those windows and doors should be permanently marked with the rating and the license number. And again, your contract should show it. If you can't get the proof of that U value, don't take the risk. Your local authority will not deem them to comply with the building regulations, and you will be told to replace them. So quickly, there's just a few others. There's more. The other two main ones are Part F, ventilation, and Part K, which is protection from falling. Part K has been there for a while. The compliance is pretty easy to prove with kite marking on the glazing in terms of safety glass. But when it comes to ventilation, then we now need to incorporate trickle vents into the windows. And then there's a host of other building regulations there that we need to be complying with whenever we're doing replacement windows and not making them any worse than as already exists. The one thing to note here is Part Q and Part O are more for your new builds. Part Q, however, is in consultation at the moment for existing buildings. We do expect in the next couple of years to see Part Q being introduced into existing dwellings. So if you're doing a renovation and you're thinking about replacing windows, seriously consider a supplier who's already got windows that are tested and certified to pass 24, 2022. And last but not least, they get a bad rep, but competent person schemes really are there to help you. They're there to support you in navigating, obtaining permission for replacing your windows and doors. Using one of these people means that you don't have to do that. If you use a Fencer, Corgi, or a Schuer certified installer, they will do the installation for you. They'll register it with building control. And Fencer and Certas and these other companies, they do check them. They check them annually. A percentage of the installations have to be audited, both pre-installation and post-installation, and they do all of that registration for you. And comes with it is an insurance back guarantee. So I'd strongly recommend having a Fencer insured installer. Thank you very much.
Excellent. Thank you, Nicola. That was fantastic. Some really interesting historic case studies, and yeah, really useful to hear about the updates to regulations. So that 1.4, you can get that with a double glazed and
Yeah,
yeah.
generally with our casements and sash windows, we're at 1.2. So
Right.
we're our windows in particular are under that, about 15% under the current regulations.
Okay.
But there are certain systems particularly UPVC and aluminium, that do struggle to achieve it. So keep a lookout for that U value.
Okay. Excellent. Well, thank you again. I'll yeah, if you could stop sharing, that would be marvelous.
Thank you.
Okay, on to our third and final speaker, Peter from Mike Y. Over to you, Peter.
Hello. Yeah, thank you very much, Richard. Yeah, nice to be here today. I'll pop the presentation on in just a second. But yeah, brief intro. I think some of you might have seen me before. I'm Peter Rollinson. I work at Mike Y, mainly with insulation most of the time these days, although most of us in the firm have dealt with most elements of the business, from lime render and lime plaster and breathable paints to insulation and all sorts of other things as well. But yeah, it's a mercifully brief rattle through foam glass and limecrete floors today. I also see mercifully I'm slightly out of focus, which is probably a good thing. Apologies if I sound a bit gummed up, but slightly afflicted with a cold at the moment. So prepare your tiny violins for that. I'll just pop on the presentation. Hopefully we'll, here we go. Can you see that? Is that all there for you?
Yes, we can see that. Thank you.
Lovely. Thank you very much. So, yeah, insulated floors. I mean, as you know, as Neil and Nicola have both quite rightly mentioned, the thermal angle of any upgrade to existing buildings is critically important now, and it's an area of ever growing focus for the folks that we deal with and our clients and the projects that we help with. Very interesting to see what Neil was talking about there, which mirrors a great deal of the territory that we find ourselves constantly going through here in the insulation team as well, in particular, to do with moisture behaviour and thermal behaviour and so on. And also, Nicola, very nice to see some proper attention being paid to thermally efficient, well-made windows that suit older buildings in particular, because I'm sure we're all aware that's not been an angle that's been perhaps sufficiently covered in years gone by. So yeah, very interesting there. So yeah, insulated glasscrete floors. Excuse me, as I said, there would be some pronunciation errors today because I'm only partially breathing. And foam glass aggregate in particular. And so in brief, foam glass aggregate, as the name suggests, is an aggregate, is made from recycled glass, which has been through a process to expand it and to create a material it's a bit like pumice stone in the hand, but it's a dark grey, blackish kind of colour. It looks a bit like barbecue charcoal. And it is from 99% post-consumer recycled glass. There's a very small amount of new glass added to it as well, but that's really just a quality control angle. And used in load-bearing foundations, new build and retrofit. There's also other applications: landscaping, drainage, road construction, landscaping and backfill, and so on. So a variety of applications. The vast majority of what we do is insulated floor build-ups, basically. The production side of the material, we sell a product called GSL, which is produced in Germany. It's produced by the sort of parent company is a firm called Veriso, who are dominant there in the recycling industry in general, but they also therefore have fantastic access to a marvelously huge supply of glass that's coming through the recycling system. The glass is ground into a powder. Raising agents are added. I think that's glycerin and potassium, so sodium silicate as well, I believe, from memory. That goes through a series of kilns where the product rises. It's referred to by the people that make it as a cake because it's the best way to describe it, I suppose. Goes up to, I think it's over 700 degrees C, possibly up to 900. As it emerges from the final kiln, it cools and it starts to fracture. As the temperature changes, it's then a little bit further pulverized and graded into the correct size. And we're using aggregate size of 10 millimeter up to 60 millimeter or thereabouts for the work we're doing. Then it's distributed. We bring in the material to our base here in West Devon in bulk, and we bag it here for supply throughout the UK. We also, excuse me, supply direct loads, loose material, for example, full loads, direct to sites all over the country, which we're very keen on because it's much more efficient to do it that way. Depends on the volume that you need. So key properties. It is primarily used for insulation, but it has a few other distinctly somewhat unique properties which make a lot of sense when you compare it to alternative materials and alternative floor build-ups. It does have low thermal conductivity. It is moisture resistant. It's made from glass, so it's a material that can be fully submerged in water as long as the water drains away, which it can do because it's free draining. There's no damage or decay or detriment to the material itself. In situ, we would expect it to remain in a dry condition. However, if it's in a building which is flooded, for example, as long as the flood water has a suitable escape route and the water can vacate relatively promptly, there's no ongoing damage, and it would also dry out a great deal more quickly than what you might call a conventional floor build-up, which we'll have a quick look at in a moment. It has high compressive strength, so it is a load-bearing element. In most of the settings we see it, it's used as an insulating subbase. Following compaction, the material has a compressive resistance of 275 kilonewtons per square meter, which equates to just over 28 tons per square meter. And for all of the domestic purposes, at least that I've seen, that's perfectly adequate. Now and again, you'll get the odd engineering question about loadings and other items. There was one recently about a mezzanine floor, which was going to be supported on pillars that were going onto the floor below, and it wasn't a complex question really to broach, but it was just a question of making sure that the loading and the footprint weren't likely to exceed the capacity of the material. It is very, very light indeed. I think a cubic meter is no more than about 150 kilos in dry weight. If you've got people handling this material on site, of course, there's a huge bonus there. So a barrow full of GSL, the foam glass, is a negligible weight really. So there's an advantage with handling. There's also an advantage in that it's not creating a large increase in loading of materials onto a site itself. We do still need there to be sufficiently bearing subsoil or substrata beneath it. So if someone's excavating to put this sort of floor system in, you always have to be assured that the ground beneath is suitably bearing. So sometimes a little bit of initial compaction of the ground may be required, but it depends what's down there. It's non-combustible, completely non-flammable, and another attribute that's particularly useful is the closed cell structure. So it's a non-capillary material. This is quite critical when we are looking at what we call a glasscrete floor in its purest sense, which is an insulated, fully breathable floor. And we're using the foam glass, the GSL, obviously to insulate, also to be a supportive layer of material for a screed or a slab that lies above it. But the fact that the GSL is non-capillary effectively means it won't work as a wick that will draw up ground moisture into the screed or slab above, or into the lower portions of the walls themselves, into the fabric of the building. So in this purest sense, if we're able to, we would have a system where there's no DPM and we're using the foam glass, the GSL, as a capillary break between subsoil and what lies above. And I think the other angle that we deal with quite a lot is the comparison between conventional floor build-ups and a glasscrete floor. The conventional floor build-up, I'm sure many of you are perfectly familiar with this, but very, very briefly, as you are likely to know, we've got compacted hardcore sand blinding. We're looking at DPMs, concrete slabs, insulated material, underfloor heating systems possibly, and a screed on the top. All of these materials represent a certain amount of depth. and therefore combined a total depth of excavation, which can be fairly considerable. Also, all of these are layers of material with their own individual material cost, and possibly most critically of all, they all represent a process for installation and therefore time and labour costs. So you may have a system such as this, which is thermally reasonably good performance, because it quite often has PIR insulation, which is low thermal conductivity. Not something we're keen on for all sorts of reasons, but it does that one thing rather well. However, there's no moisture management benefit with this type of floor system. And what we would often fear that we would see, especially with retrofit in older buildings, the use of impervious floor systems can, in many cases, under hydrostatic pressure, cause ground moisture to accumulate and to be pushed laterally into the feet of the walls, creating damp problems and associated issues there. So in itself, this conventional floor build-up it's thermally effective, and it's likely to, if installed correctly, give you a nice dry floor. But it's a deep total sort of system with many layers, and although, as I say, thermally efficient, excuse me, in moisture management terms, it's not really very effective. It's a bit of a blunt instrument in a way. Here we have an example of what we would expect to approach retrofit with in an older building, or indeed, any form of retrofit. There are new build applications as well for GSL for foam glass, which we'll have a quick look at in a minute. As you can see, the virtue of simplicity, in essence, it's two ingredients really. You've got a layer of foam glass aggregate underneath, and then you've got a lime screed on the top. In addition to this, we would use geotextile membrane below the GSL and on top as well. It's really a separation layer. It's just to prevent material migration from one zone to the other. In this case, also illustrated, we have an underfloor heating system, a wet system, that is generally fixed through to clip rails, which are fixed to E-grid, which is a plastic grid, laid on top of the GSL, and then the lime screed is basically put directly onto that, and the underfloor heating is embedded in the base of the lime screed. If there's underfloor heating, it will be 100mm thickness of screed that's advised, and final ingredient really, a strip of cork at the perimeter, which is there really as primarily a thermal break between the screed and the wall, but also it's a decoupling item because it's moderately compressible material. If we do see any minute expansion in the screed over even just on a seasonal basis, it will therefore prevent those forces being transmitted to the walls. So it's thermal and decoupling as well. And as I mentioned, a very straightforward system, fewer processes. The material cost may be lower, or it may be a bit higher, depending on the relative depths of material. However, on the labour side of things, we would expect to see significant savings with this type of floor system. There are also, as I mentioned, very important gains to be made with moisture management in particular. GSL, the foam glass, is completely vapor open, fully breathable material. Therefore, we won't see an accumulation of moisture on the underside of the screed, for example. And if there is a bit of vapor transfer, it can pass through into a lime screed and happily breathe away. This doesn't indicate a floor finish. We have a preference, I would say, for tiles and stone. Slate, flagstones or similar all work really well. Bedded in a lime-based bedding material, tile adhesive, or an NHL mortar, natural hydraulic lime and sand, which is what the screed is made from. It's sharp sand and natural hydraulic lime, NHL5. Alternatively, engineered timber is a good option as well. We would normally have that laid as a floating floor. If we're into the realms of using more traditional floorboards and so on, not engineered timber, then that does raise a few more questions about fitting. But we tend to approach that perhaps more case by case. And It's not to scale as such, this diagram, but one thing we're always talking about is how do we assist in someone specifying this type of floor system? And we're looking at U values, as you can imagine, and we're also taking into account with retrofit, where are the constraints that we have to operate within in terms of excavation depth, final floor level, ceiling height, and so on. What we'd expect in most domestic retrofits to see would be a GSL foam glass layer of somewhere between 150 millimeters and up to about 250. It's usually within that range somewhere. You can go further with the material, and at the absolute minimum, you can do 120 millimeters of compacted thickness, but we tend to say 150 is a good bet if nothing else is known. But between 150 and 250 is likely to give you the sort of U values that you need. There's no single depth which will apply to a given U value across the board. We're very happy to do U value calculations with people. We spend a lot of time doing that sort of work. And it's a combination of the floor area and the length of the exposed perimeter that we take into account. So there's no single depth which gives a set U value in all cases. But as I mentioned, in most situations, we'd expect between 150 and 250 mil. Screed on the top, 100 mil if there's underfloor heating, 75 without, and then floor finish as the final item. In new construction, this does include, as I'm sure you can see, a DPM, damp-proof membrane. As I'm sure many of you know, with building regs, if it's a new build, you're going to have to use a DPM. It's almost always insisted upon. We would perhaps prefer not to. However, the foam glass still works perfectly effectively beneath a DPM. In fact, in continental Europe, where it comes from, excuse me, it's almost exclusively used under concrete. We would lay the DPM over the foam glass, and then in that case, because we've got an vapor impermeable layer of material there now, we would tend to say, yes, you could use a lime screed, but in most cases, people will opt for a cementitious concrete screed, which is likely to be a little bit slimmer than a lime version, and possibly a little bit quicker and a little bit cheaper as well. But as you can see, with a strip footing, the GSL foam glass occupies a space inside the ring of the foundation, as it were, and we would simply seek to see that the components are correctly configured, so we have no issues with the capillary transfer of moisture there. And taking it a stage further, perhaps, with new builds and perhaps aiming for the lowest possible U values, so passive house kind of territory, it's not uncommon to have a concrete raft foundation, and you would start off with the entire site being cleared out and excavated to required depth. In that sort of setting, you're likely to see the foam glass component probably somewhere between 300 and 500 millimeters in thickness, maybe even a little more. So on a reasonably sized building, yes, there's quite a volume of material there. However, it's a load-bearing insulating material, so it's doing several jobs at the same time. So yet again, the material cost might be a certain figure, but we would be very keen to take into account the reduction in other associated costs. It is a material that goes through a stage of compaction. It's laid as a loose fill, roughly leveled, and then compacted. We'd normally be looking at a compaction ratio of 1.3 to 1. So you'd effectively look at your final volume in situ and add 30% to account for the compaction stage. And the compaction of the GSL is, it's not pulverizing the material and smashing it up. It's more that the vibration and the weight of the kit that you use is going to shuffle and push it down into and among itself. And the nature of the material is the fact that it's very high friction, and the lumps of aggregate are irregularly shaped and quite jagged and angular. As you can appreciate, during a compaction phase, this depression of the material by 1.3 to 1 effectively wedges it into a matrix of material which is incredibly stable. When it's then contained in situ, it's got something on the top, something at the sides, obviously something underneath. At that point, it's not really going to go anywhere. We wouldn't expect any settlement at all. if you were looking at a case where you were having a higher load bearing capacity, in some situations it might be a higher compaction ratio of 1.6 to 1, for example, but generally we don't find we need to get into that territory. Couple of brief items that crop up from time to time, using foam glass, using GSL. As you can see, sorry about the slightly blurry pictures. In this case, someone has been using it for perimeter drainage around the external side of a property. You can also see there's a higher ground level situation going on there as well. So amidst other works that are clearly in progress there too, I won't comment on the render type there, which looks slightly distressing, but we won't go there. As you can see, we've effectively got pea shingle in the base of the drain. We've got the perforated pipe wrapped in geotextile, and then we've got a layer of the foam glass GSL on top, which would then be capped over again, geotextile on the top, and then other material, be it gravel, pavers, and so on. The advantage with this is clearly that it's free draining, and as a drainage medium, highly effective. The other advantage is it's lightweight, so you're not putting in many tons of material. You know, if that was filled with hardcore, you'd probably be looking at, just in that photo, anything from 4 to 8 tons of material quite easily. Whereas in this case, I would say that's probably about 500 or 600 kilos of GSL at the absolute most. In addition to the drainage, it's also providing a thermal break. It's a little bit of thermal isolation for the foot of the wall from the subsoil. So it has a positive contribution to the bigger picture there in the round, as it were. So useful for that sort of thing. Very briefly, district heating, not something very prevalent in the UK, although it should be, and it probably will be as time goes by. Much more popular on the continent, where they seem to have a bit of a talent for forethought, you could say. But again, very useful material, highly stable, but obviously in the case of a heating system, providing that extra layer of thermal isolation from the heating conduit itself and the subsoil. So something we would hope and would like to see more of. There's been a lot of work, I know, with movements towards ultimate net zero and so on, and how we can reconfigure the systems that we live in, and district heating is going to be a very important component of that, hopefully. Also, very briefly, I don't think I've ever dealt with a project from Sports Arena, but I know other people have. We've dealt with some other larger projects too, which have been quite interesting, but not in the UK, to my knowledge, one of these, but I could stand to be corrected. But as you can imagine, free draining, highly stable, very useful. There's a stadium in Europe where this was done, and the advantage there was that there was a car park underneath. So this layer of lightweight aggregate was fantastically useful because of lightweight as much as anything else. That's a railway tunnel, I believe, embedded there. Yet again, as you might spot, quite clearly not in the UK. I'd really like it if civil engineering projects like that were to adopt GSL, but it's a slow process there. But yet again, used because of stability and lightweight, basically, and a free draining nature. And something which crops up fairly rarely, but it's always an interesting one, an insulating sub-base and sort of surrounding jacket for a swimming pool. So yet again, very useful, thermal isolation and stability and load-bearing properties. So not something, as you can imagine, that's in everyone's backyard in this country, but there we go. So that hopefully